I'd like to welcome all of you on behalf of the Pakistan Academy of Engineering and its President, Professor Dr. Jamil Ahmed Khan. I would like to start the proceedings of today's proceedings by requesting Mr. Hafiz Mustafa Ahmad Sharif, the Manager Operations, Pakistan Academy of Engineering, to recite verses from Holy Quran.
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم لقد أرسلنا رسلنا بالبينات وأنزلنا معهم الكتاب والميزان ليقوم الناس بالقسط وأنزلنا الحديد فيه بأس شديد ومنافع للناس وليعلم الله من ينصره ورسله بالغيب إن الله قوي عزيز. Translation. Indeed, we sent our messengers with clear proofs, and with them we sent down the scripture and the balance of justice, so that people may administer justice. And we sent down iron with its great might, benefits for humanity, and means for Allah to prove who is willing to stand up for Him and His messengers without seeing Him. Surely Allah is all-powerful, almighty. Sadaqallahu al-Azim.
I would now request the presidential address from Professor Dr. Jamil Ahmed Khan, the President of Pakistan Academy of Engineering. Over to you, sir.
Bismillahirrahmanirrahim. Respected speakers, my dear fellow engineers, honorable guests, ladies and gentlemen. Salamun ala man ittaba al-huda. Instrumentation is the backbone of scientific research, industrial progress, and technological innovation. From healthcare to agriculture, manufacturing to energy, and defense to environmental monitoring, precise and reliable instrumentation enables us to measure, analyze, and optimize systems for enhanced efficiency and productivity. Without robust instrumentation, infrastructure research outcomes remain limited. Industrial growth stagnates, and technological advancements are constrained. The global process instrumentation market was valued at over $17 billion in 2023 and is projected to grow at a CAGR over 3% between 2024 and 2032. The growth highlights the increasing importance of advanced instrumentation in various industries worldwide. To keep pace, Pakistan must invest in modernizing its instrumentation infrastructure. India, in contrast, has strategically developed its local instrumentation industry and invested in R&D. Its government policies support domestic production, reducing import dependency, and enabling self-reliance in critical sectors. Today, the industrial automation and instrumentation market in India is projected to grow by $26.57 billion between 2024 and face calibration and manufacturing limitation. Trade restrictions further hinder access to advanced tools, affecting key sectors like healthcare, defense, and energy. Addressing these changes requires implementing efforts, strategic partnership, and investment in local instrumentation development. To build a strong, self-sufficient Pakistan, we must prioritize investment in instrumentation at multiple levels. The following key areas require urgent attention. To overcome these challenges, we must localize instrumentation manufacturing to reduce imported dependence and create jobs. Upgrade research facilities with modern equipment. Develop skilled workforce, train in calibration and maintenance. Enhance industry academic collaboration for technological innovation. Ensure policy and funding support to promote self-reliant instrumentation. Let us recognize that instrumentation is not just about measurement, it is about progress, precision, and prosperity. I urge all stakeholders present here today to contribute their expertise, insights, and recommendations to drive a transformative change in Pakistan's instrumentation landscapes. I extend my sincere gratitude to the esteemed speakers for their valuable contribution to this symposium. Together, let us pave the way for a future where Pakistan stands at the forefront of scientific and industrial innovation. Thank you, ladies and gentlemen.
Thank you, sir. Finding a topic which is worth the national direction could only be conceived by Professor Dr. Jameel. We need focused attention on instrumentation development in Pakistan, and for that we have several speakers coming in. But let me admit one thing very important today. I see our friends from China in a big number today. Mingxi, Zi, Dr. Wu, Dr. Tao, Dr. Jiang Wang. I can't read Wang Ji Yang. I can't read the last name. I need to learn Chinese to read the last name. I wish she had written the name, but I can't read that name. Thank you anyway for joining us. Hopefully we'll benefit from your presence. Do share your views. I would now request our first speaker, Dr. Shoaib Usman, who is Associate Professor of Nuclear Engineering and Radiation Sciences at Missouri University of Science and Technology, Missouri, USA, to give us his talk on industrial medical application of nuclear radiation detection. Over to you, Dr. Shoaib Usman.
I'm Shoaib Usman. It's an honor and a pleasure to be with all of you.
Yes.
I'm going to talk about radiation measurements, which has been one of my areas of research. I'm coming from Missouri University of Science and Technology, a relatively small campus, but STEM dominant. 18 BS programs in engineering, 21 MS, 17 PhDs, with a generous gift of $300 million from Fred and June Comer. We have established a new college. We just received our highest ranking. There is R1, and this is our faculty. Very small size for nuclear engineering currently. I'm proud that one of my ex-PhD student, Typhoon Ekwarik, has also joined our faculty. So this is something that I'm proud of. This is our campus-owned reactor, not very far from my office, maybe 30, 40 yards away. And this is the close-up view of the core of the reactor on the right-hand side. That has given us a lot of flexibility to do research on radiation detector, radiation measurements. And that has been one area of my research. Little bit, I'll talk about my own background before we get into nuclear instrumentation, medical application, industrial. Then I will talk about reactor instrumentation in particular rather than just radiation as an example. On the right-hand top corner, there will be a red tag which now is saying background, my background, which will give you the situational awareness where we are in this presentation. So having said that, let me continue. So this is where I'm coming from. Surely from NED University of Science and Technology, that's where I got my BE, Bachelor's of Engineering in Mechanical. With an apology for non-Urdu speaking, I would say something in Urdu. काबे से उन बुतों को भी है निस्बत दूर की, वहाँ के नहीं तो वहाँ के निकाले हुए तो हैं. So we are coming from NED and we have a very close relationship in our heart for NED. And we would like to help the institution as much as we can. Rest of my degrees were from University of Cincinnati in nuclear engineering, health physics, and nuclear engineering. This is my area of research. On the top, you will see the number of publications in different areas. So thermohydraulics has been one of my major areas, followed by radiation measurements and detection, and spent fuel interrogation. Both of those would involve radiation measurements and improving the quality and or performance of detectors, radiation detectors. I have not made any detectors myself, but I'm very well aware of their performance. In thermohydraulics, my research area has been in critical heat flux, natural convection, natural circulation, passive reactor safety, and this is showing one of the loop that we built on the right-hand top corner for natural circulation, and the bottom left-hand corner is showing the instrumentation that we had developed for measuring simultaneously temperature in the flow, velocity variation, radial variation in the flow, and heat transfer coefficient. So all of those measurements were made simultaneously. Another area of my interest is heat transfer enhancement using twisted tape or other techniques. Some initial results, axial temperature profile at the top, radial temperature profile at the bottom. And recently we are working on new reactor concepts are using molten salt as both fuel and the coolant. So our interest is on time to drain in case of an accident. The plan is that from this critical configuration of the reactor fuel / coolant, it will drain out to subcritical configuration. How long will it take to drain it out? That will really dictate how much heat needs to be removed in the subcritical configuration. The other area is radiation measurements, radiation detection. That is something of interest to this audience. And there I am more interested in detection dead time, meaning when the one pulse is one event is registered in the system, and we will talk about that in a little bit more detail. There is a dead time during which another event, another radiation interaction cannot be recorded. That has influence not only on the count rate, but spectral convolution will take place. So these are some of our results. Of course, we have a series of 10 to 15 publications in that area. And most recently, we are working on the statistical degradation of Poisson. So there will be a distortion of Poisson distribution when the radiation events will arrive at the detector. They will be ideally Poisson, but as the signal is passed through the detector, the preamplifier, amplifier, and thereafter, the Poisson statistics is impacted, And now we are looking at the variation, the change in the mean, kurtosis, chewiness, and phenofactor, how they are being impacted. And from there, really predict how many counts are lost. The other area is in proliferation and spent fuel interrogation, so anti-proliferation tool development. And these are our results. So we are the first one, the middle bottom picture, we are the first one to report multidimensional delayed neutrons. Delayed neutrons are usually reported in 6, sometimes 8 delayed groups, but no mention of the energy distributions within each one of those groups. So we are the first one who had divided those each group into energy distribution. Some of those pictures are shown up in the top. The spent fuel, which was older than the newer one, how that spectrum will change, the neutron energy spectrum will change. Bottom left-hand corner is showing the core configuration of our campus core and the beam, neutron beam, and the detector at the very end. I'm sorry, the picture is too small, but using this beam, we were recording the neutron energy spectrum. We have done both delayed neutron spectroscopy, prompt and delayed neutron spectroscopy. The big picture in the center or bottom center is the system that was developed by the ex-student that I mentioned in the very beginning, Typhoon Equirek, at his campus when he left us after graduation. He joined another campus as an assistant professor. That's where he built that. This is capable of being lowered into the reactor pool, grabbing one of the fuel element, bringing it up in the dry area. The bottom has a jack which can move the fuel element up and down. There is a port for neutron activation and multiple ports for measuring gamma as well as neutrons. Since these ports are at 180 degrees apart, we can do coincidence measurements, we can do anti-coincidence measurements. So all of those were our capabilities, but fortunately or unfortunately, he left the program and started at our campus as a faculty, Typhoon. So he had to leave this apparatus behind. We will be rebuilding it together on our campus. The next area is in radiological pathway analysis. We are looking at atmospheric transport of pollutant and surface water, groundwater. My focus is only on atmospheric and groundwater. Some of the experiments here. In US, it is required. Can you all hear me?
Yes, we can.
Okay. In US, NRC, the regulatory agency, NRC requires that you collect 3 years of historic data before you can submit an application for a site license, which means there is inherent 3 years of waiting time. What we have done is we have used off-site data from airport and weather stations, and using that, build some correlations. So synthesizing the off-site data to supplement on-site data. Very good results. As you can see on the top, atmospheric stability is very well predicted. No more than one stability class prediction difference, except for a couple of points like this one. The bottom right-hand picture is showing the rate of transport of strontium and cesium through groundwater. We got sample from overseas. I'm not allowed to name the country, where they were thinking about building a test reactor and they wanted to see the radiological impact of such an activity. So they sent us soil that we tested for its permeability to pollutant like cesium and strontium in this case. And what I'm seeing in this picture is typical RC circuit. and we are modeling it using RC circuit analogy. What we are saying is that the resistance to that is the reciprocal. The resistance to the transport is the reciprocal of the hydraulic conductivity, and the capacitance of this equivalent circuit is the retardation coefficient or distribution coefficient of these elements in the soil and water composition that is present at that site. So the water chemistry has to match. My other areas are not really related to measurements, so I'm not going to talk about it, but supply chain and understanding the codes and standards that are applicable to nuclear industry is another area of my interest, but I'm not going to spend a lot of time there. So our focus will be only in these two gray ellipses, radiation detection and proliferation and spent fuel interrogation. So first of all, and I must have written it down here that this information is not new. All of this is coming from my other publications and or teaching. So I'm just summarizing those. So like any other measurements, and I'm giving an example of length measurements, depending on what you want to achieve, there are different tools. As you can see here, measuring tape versus a ruler versus a vernier caliper, so on and so forth. There are different tools, and you need to pick the right tool for the measurement that you want to do. Radiation measurements is no different. Same. You need to understand the application, and with that application, the limitations, and then you pick the right tool. So I give this example very routinely in my class. I would say that measuring by a vernier caliper, marking by a chalk, and then finally cutting it by an X. It makes no sense to use your resources in accurately measuring when you could not really mark it well, and then marking it very accurately has no value if you cannot cut it exactly where you want it to. So this is reverse of that, and in all engineering measurements problem, one needs to know limitation and the choking point in your measurements before you go forward. So radiation measurements, many of you may know that the first step is the detector itself. Then comes the preamplifier and amplifier, where the signal from the detector is really processed and then recording it in either a counter or in multi-channel analyzer or observing it in an oscilloscope. The question is, if I have deteriorated my signal at the very first stage of detector, then there is no way I can do improvement in that later on. Likewise, and that's where the example comes that if I need a vernier caliper here, but my amplifier and preamplifier is not really capable of supporting such a high quality data, there is no gain in spending any extra time or money trying to improve a signal which is already deteriorated. So this is just a picture of amplifier, picture of single channel discriminator, and a counter. Crude, but essentially they come with the standard shapes which will be on a NIM bin, nuclear instrumentation module, and the bin is that where they can slide in at the back. The connectors are classical standardized connectors for power supply and signal processing and whatnot. So detector usually generates a very faint, very small looking pulse. Now, there are different choices for the detector depending on what you want it to measure, starting from gas-filled detectors to scintillators to semiconductors, and now there are some exotic scintillators are coming. Anyhow, that signal now goes to preamplifier where it is amplified, and a long tail is added to that. So this is a tailed pulse after amplifier, and then a preamplifier, and then in amplifier, try to shape that pulse, and then you take it out, and either you do its discrimination based on the pulse height and do analysis on multi-channel analyzer and sort these pulses based on their height, which is MCA, and then count them. Different type of detectors shown in this. So these are high purity germanium detector, gas fill detectors, high purity germanium modules, and some others. Now the question is, what are the characteristics that we are looking for with radiation detection? Are we just trying to detect whether there is radiation or not? That's the first level. Second level would be that we want to measure the intensity of radiation, meaning how many interactions are taking place per unit time in your detector. So you're measuring the intensity of radiation. Third level could be that you want to do a spectroscopy, that you want to not only measure and count them, that so many interaction took place in my detector per unit time, but you want to sort them out based on the type of radiation and the energy distribution from those incoming radiation. And mode of detector operations could be current mode, meaning all you're doing is measuring the current passing through this detector, which is giving you the intensity of radiation. Obviously, when you're operating a detector in current mode, spectroscopy is not possible. You have lost the details of each pulses. The second possibility is that you take each one of those pulses separately, process them separately. That's where you can do intensity as well as energy measurements. And the mean square voltage, for now, we will not focus on that very much. We will touch on it slightly. What are radiation, ionizing radiation and non-ionizing? Within ionizing radiation, everything here in this picture with white color is indirectly ionizing radiation, meaning they do not have a charge. Neutron does not have a charge, gamma and X-rays. So they create ionization indirectly, and charged particles like proton, electron, positron, alpha particles, charged nuclei, they cause ionization directly. They, being the charged particle, can potentially ionize the material it is passing through. In the process, they have either created electron and hole pair if it was a semiconductor material, or electron and a positive ion if it was a gas or something. And all we are doing is collecting this charge produced by radiation and then making a pulse out of it and processing it. So what are the desired characteristics of radiation detector? Number one, space resolution. So we want to be able to resolve the space either of the radiation source. Where is the radiation source? You don't know, but you would like to find out. Or you know the location of the radiation source, but you want to picture a target or a shielding material very similar to X-ray. And your desire is to improve the spatial resolution of that image. Second thing is energy resolution. So you want to be able to differentiate the energy of the incoming particle, may it be gamma, may it be neutron, that how two very closely spaced energies, unit of energy in nuclear is MeV, mega electron volt. So can I distinguish from 1.000 to 1.1 MeV separately? And that will be called energy resolution. And the last one is timing resolution, if two of these pulses are coming very close to each other in time, is my system able to treat the two pulses separately? Then, of course, the other thing would be I should be able to resolve one type of energy to the other type of energy, response of different type of radiations, be able to differentiate different type of radiations one from the other. Cost, of course, initial cost of that device and the operating cost of the system. Durability, size. At times you do not have the luxury of placing a very large volume of detector. Suppose I wanted to make measurements within the nuclear reactor core, and I wanted to see the energy distribution and the neutron flux at different locations in the core. Volume available there is limited. So essentially it's an optimization problem. And like any other optimization problem, you do not solve the puzzle by looking at one side only. You will have to pay attention to all sides simultaneously. And their relative importance may change based on the resources that you have available and the results that you want to achieve. This is the very first X-ray, and I will take the humor part of me out on this. So this is the very first X-ray ever taken. So Rankin took this X-ray, and that's where my humor part will come, that this is more revealing than an ordinary person would see. First of all, our belief that the first generation of radiation worker were unaware of the harmful effect of radiation is not true. Pay attention. This is his wife's hand. He did not experiment with his own hand first. That tells us that he was aware of the harmful effect of radiation. Secondly, the professors of that era were paid significantly more. They were paid significantly more than today's. Look at the size of this ring. I don't think professors of this era can afford that. Nevertheless, that was the humor part. Let's move on. So this level of space resolution is now improved into this. And you can tell the world of difference in the space resolution of first picture to today's X-ray. And this is, of course, a picture. As an honest scholar, I would like to give credit to where these pictures are coming from. So space resolution improvement. Other application is medical. Again, source detector geometry. Sometimes you have external source and external detector, like in the case of X-ray and CT scan. Or you can have the source of radiation injected into the patient, so internal source and external detector. PET scan is internal source, external detector injected into the patient. So there are many choices of isotopes there, and those are listed here. I will not go through each one of those. Industrial applications, before we go to the reactor itself, oil and gas industries using that for well logging, active interrogation of using neutrons, bulk density and neutron porosity measurements, civil engineering, we are using it, moisture contents, rebars in the RCC construction, mechanical, we look at the welds using radiation, structural steel, corrosion. For manufacturing, we are looking at metal thickness, coating thickness, aircraft inspection, chemical industry. We are looking at chemical reactor column scanning. We are looking at a specific gravity of their chemistry. Fire safety, smoke detectors would have radiation in a detector. Cargo, You have all been to airport and screening there, custom and arm control. So these are the industrial application. As an example only, we want to look at nuclear reactor. The reason I'm talking about nuclear reactor, I'm most comfortable with that. We have a reactor on our campus, and I have been teaching reactor labs for over 2 decades. So I will talk about that in specific, but I also teach classes on nuclear power plant licensing. So commercial reactor, what do they use? And then we will talk, or we will have some time to discuss what is the potential for developing new detectors, or at least existing detectors in a country like Pakistan. So fission chambers, as the name says, fission is caused, neutron cause fission, and we really count the pulses generator. So essentially you have fissile material next to the wall, radiation comes in, neutrons cause fission, one of the fission fragment goes into the gas, cause ionization there, and a pulse. And since the pulse is coming from fission fragment, a lot of energy, roughly 100 MeV as opposed to few MeVs of gamma, we can draw a discriminator line that, only pulses above this pulse height will be counted, and you're only counting pulses generated because of fission. And if you operate them in current mode, then you can say that this is for a given flux of 10 to 12, and this is for 10 to 14. After a nice high operating voltage, you can tell the neutron flux based on the current passing through fission chamber. In most cases, you use fission chamber for a startup in pulse mode, and then you move it away because you want to preserve your detector live when it is at full power. And this is the interaction taking place in a proportional counter. So you have boron, in this case BF3 gas, interaction taking place there, and lithium and alpha particle coming out. Alpha is particle has some energy. It will cause ionization of the gas, pulses generated, you count that, or you operate it in current mode. Again, gamma can also cause ionization there, and there is a noise because of gamma. Now, X-core instrumentation, meaning outside the core, not between the fuel element. What are the options? Monitor neutron flux outside the reactor vessel or core. Initial alarm and control systems are relying on that. So these are your ears and eye in the core, what is happening in the core. And you rely on that in all decision making about the criticality of the reactor and behavior of the reactor, relying on what signals you are receiving from this. Provide necessary overpowered trips in commercial reactors. So if there is an issue, there are tools, statistical tools available where you will start changing the weightage coming from different detectors with the idea that if repeatedly there is a sudden change in that signal, you discount that signal. So instrumentation associated with each channel is located in the control room, of course, and you make measurements there. For different stages of reactor operations, which means source range when you're just starting the reactor, intermediate range, and power range, and finally wide range. I hope I'm not going over my time limit. Otherwise, I can accelerate my discussion.
You have 6 more minutes to give your presentation.
Okay. So for source range, you usually use something in pulse mode. There is still significant amount of gamma present there. So what you would do is ensure that you can discriminate against gamma. In the intermediate range, there is significant gamma, but neutron count rate is so high that you cannot operate it in pulse mode. So you would rather use it in current mode, and yet you need to discriminate against the gamma signal. So what you do is you put a compensated ion chamber where one of the detector is lined with neutron absorbing material, the other one is not, and you subtract the current from the neutron plus gamma. The gamma current is subtracted, and this is giving you the neutron intensity. I'm not going to go into details of what is the operating voltage, but these type of detectors are called compensated ion chamber. For power range, your neutrons are the significant component of the radiation and gamma becomes insignificant. So uncompensated chambers in current mode is commonly used. Now you will have array of that in commercial reactors. I will not go into the details of how they are distributed within, outside the core or within the core in some cases. And wide area, you want to cover 12 order of magnitude variation. I'm so sorry, I'm going a bit faster. Wide range of operation signals. You can operate in both pulse mode for some level and then current mode. Split the signal to drive the signal processors. Now coming to the general area of what we can do in Pakistan. First of all, we need to know which area is already developed. Are the electronics well developed? As I said very early on, we don't want to be measuring by a vernier caliper, marked with a chalk and cut with an X. We don't want to do that. So, assuming that all of this is well developed, then we want to know what is the need in this area. Is it reactor instrumentation, medical instrumentation? And then based on that, that type of detector needs to be developed. So gas filters are rather crude detectors. The type, the control on the gas composition is what it matters. Of course, with the purity of the central electrode and the walls and making it stable. But it's very simple. The scintillator detector, where the interaction of radiation produces a spark of light, which is then read by a photomultiplier tube, and photomultiplier tube converts that light into an electric signal, would require some work. And then if we have some semiconductors industry available, then we would look at the possibility of looking in creating a PN junction, reverse biasing them, stretching the voltage to create a depleted zone, and any interaction in the depleted zone will produce electron and hole pair that will produce a pulse that can be read later by the subsequent electronics. So I do not know enough to comment if the subsequent electronics is already available. If so, what is the quality of that? And what is the status, I don't know, of detection development. I don't know, but I'm very willing enthusiastically to help in that process. In fact, I have visited NED several times to start a health physics program or medical physics program. These are some of the regulatory, not standard development organizations. IEEE will play a significant role here. This is my last year, 2024 in history. Some students went with me to reactor site. I visited Turkey, Nurar conference. I visited Chicago public engagement to discuss the idea of having nuclear power. Another nuclear power plant. So we went at a boiling water reactor plant and a pressurized water reactor, Istanbul Technical University trip, my PhD graduating, and finally my trip to IAEA as a delegate about supply chain. But the most significant for me, 2024, was that we were blessed with two granddaughters, Yusra and Rayana, and these are my motivations to continue working and producing things. I want to leave a better world behind me for them. So with that, I can conclude. If there are any questions, I'm sorry, I went a little bit too fast after asking the question that I have only 6 minutes.
I wish we could hear you over 2-3 hours continuously. However, it was really great to hear from you and learning on radiation measurement and instrumentation. Thank you so much, Dr. Shoaib.
Thank you.
We now
Thank
request
you very much.
Yes, sir.
if the audience has any questions, I could take out a minute or two before I request Mr. Mahmood Shah. Is any question from anyone? Otherwise, I move to Mr. Mahmood Shah, who is Chief Engineer.
I have a question.
Sure. Ahmed?
Yes, I'm Dr. Ahmed Hussain. Good to hear you from Shoaib bhai after a long time.
Yes.
I just want to ask you about the progress that we had been made in the health physics. Like the workers, they are working in the nuclear reactors. They have normally pocket dosimeter, and we only rely on the dose on that. Okay, it's a number. There's a number we always get. But how's the effect of that number in their long-term life? Is there any measurements, any analysis have been done? After they retire, as I see my colleagues in Canop, their life expectancy is not as much as I expect from the other domains people are working. So it's not only the cancer; is there something else also that affects the health? So do you have any understanding about that measurements?
I have no specifics of what you're talking about, but in reality, pocket dosimeters are only measuring external dose. So if they were internally exposed to any type of radiation that is not recorded in the pocket dosimeter, suppose they were inhaling something containing radioactive material, or they ingested something, because whatever we inhale, it goes to our lung, it comes up to our throat, or what they call nasal pharyngeal region from our pulmonary region, and that is swollen into the stomach. So whatever is going into their body, that information is not available to us. We are only talking about external sources of radiation through your external dosimeters. Having said that, I have no specific knowledge. I believe that a country as large as Pakistan, we should at least have one program in health physics in the country, because not only radiation workers at the nuclear power plants are exposed to radiation, many health practitioners working with extreme level of radiations, either for therapeutic application of radiation or diagnostic use of radiations, are exposed to radiation. I don't know how they are being monitored, how they are being protected. I have no knowledge about that, what is happening in Pakistan. But I know that such a large population should have at least a couple of health physics programs in the country. And I don't know if there is any. I have visited Canadian camp, right?
हमने रेडिएशन को हरा दिया है, फिक्र ना करें आप.
Acha. No, but I have been trying to champion the cause of starting at least one health physics program in the country, where you guys should decide outside of the nuclear power arena.
Thank you, Dr. Shoaib. We move over to the instrumentation resource in Pakistan, which will be given by Mr. Mahmood Shah, who is Chief Engineer and Director, Instrumentation, Control and Design, Pakistan Atomic Energy Commission. And I would, before I request Mr. Mahmood Shah, Dr. Mahmood Shah to come in, I would request all of you to kindly come on direct video so that I can take a picture of the wonderful gathering we have. Thank you. We move over to our presenter, Mr. Mahmood Shah. Over to you.
Thank you very much. Are you people hearing me?
Yes, very clear, very clear.
Yeah. So I'm going to proceed with my presentation. INC profile of ICCC. When I received your invitation for instrumentation in resources in Pakistan, so I was thinking whether I should present my talk on the instrumentation resources that I know spread through Pakistan, or whether should I present myself as one of the instrumentation resources in Pakistan. So I decided for the later one, but the audience will have a flavor of both of these concepts. I'm moving next. Yeah. ICCC is basically a Directorate General headed by Dr. Muhammad Irfan. And there are four main directorates in this organogram. I'm not mentioning the admin, the procurement, the accounts, the stores. But one important department that I must have mentioned is the quality department. The quality department, the quality management system, QA/QC, that is directly reporting to Director General ICCC, and they are looking at all matters of all the directorates regarding quality assurance and quality control. Now coming to my directorate, moving back, system engineering is primarily focusing on or working on robotics, some artificial intelligence, and they have significant contributions on our plants. Modeling and simulation, in this section, the full scope training simulators for our nuclear power plants at the Chashma nuclear sites that are our flagship projects. And support engineering is one of the directorate that plays some pivotal role and supporting all other directorates for mechanical works, for electrical works. But there are two key areas that will be of interest to the audience and that I will talk later on in this presentation. Directorate, when it comes to directorate, I'm Mahmood Shah, Director of Instrumentation and Control Systems. I have two deputy directors and one project director at remote site in Chashma, at the Chashma nuclear power generating stations. Industrial control systems and plant automation systems, they look very similar, but they have distinct portfolios because we have a great number of projects. So the projects are divided horizontally, and every division is playing its role. In electronics division, under the Deputy Directorate of Instrumentation, we are developing some indigenous products and very latest products based on FPGA that we will talk on some in this presentation later on. And in process instrumentation, where it comes to the measurement of pressure, temperature, flow, level, pH, conductivity, and so on. And luckily, one of our division is nuclear instrumentation, and that will be very, very beneficial for Pakistan if we can have some connection with Dr. Shoaib. He was the field he's working on is very, very prestigious and very, very demanding area for Pakistan. If the atmosphere allows, because we are facing some embargoes in this sector, but we would request the university, and later on we will try our best to have some connection, please. Going first, our mandate, the mandate of my directorate, CNPGS Chashma Nuclear Power Generating Station and Karachi Nuclear Power Generating Stations, they are the biggest clients of our organization on the open side. Their nuclear, basically we are a centralized ICCC. ICCC means Instrumentation, Control and Computer Complex. We are a centralized organization providing INC services, systems, and technical supports to almost the whole of PAC. On the open side, on the other side also, we are having 3 research reactors, 2 operational, one under construction, and we are having 4 nuclear power plants operating at Chashma Nuclear Power Generating Station, and 1 in decommissioning stage in Karachi, and 2 recently commissioned and in operation. And we are having a large number of industrial plants, chemical plants, and some other plants. The scope covers both systems and services. When it comes to services, we are providing services for a big number of services. But what service? Just one service that I would like to mention over here. On these power plants, we are having a containment, a mandatory test for the containment, a periodic test, that is the leakage test and the structural integrity test. These are 2 different tests, but they are combined. They are applied and they are performed at the same time, where the containment is pressurized in a definite sequence to its design pressure, and then depressurized gradually. And when it is pressurized to the full design pressure, we maintain it over there for 24 hours and measure the leakage in terms of loss of mass from the containment. And we have a large number of embedded strain gauges. We install almost in Karachi, we install 93 sensors: humidity, temperature, pressure, and some strain gauges. They are embedded. Some RTDs, they are embedded in the civil structures. These 2 tests previously were performed by Chinese, and they were performed by 2 different Chinese companies, and they charge almost $3 million for performing these 2 tests. We have made these tests indigenously, and we have performed on K2, Karachi Nuclear Power 2 and 3 this times, in the last times in 2022 and 2023. And later on in 2024 on one of the CNPGS site. These tests we have made indigenized. This is one of our proud. Since we are on the nuclear side, we are dealing with the safety instrumentations. So license is a mandatory element. License has some legal aspects. Without having license, we are not authorized to perform those kinds of jobs. So the Nuclear Regulatory Authority in Pakistan is PNRA, having its headquarters in Islamabad and regional offices Karachi, Chashma, and some other areas of Pakistan. All our plants installed so far, they have analog instrumentation. The reactor protection system or the emergency safety system, they are based on analog instrumentation. So far, we are not having any kind of digital instrumentation for these systems. So that wise, our licenses from the PNRA are also in the analog technology. They issue design license separately and manufacturing license separately. We have acquired both for the research reactor, and very recently we have acquired the manufacturing license for manufacturing analog instrumentation based reactor protection system for the nuclear power plants in Chashma, and the design license is under progress. Similarly, we are a ISO 9001-2015 certified institution, quality management system requirement, and this ISO 19443. This is an extension of the 9001 standard. This standard is gradually adopted by the nuclear industry, and we also approached for acquiring this system, this certification from PNAC, Pakistan National Accreditation Council, with headquarters in Islamabad. But unfortunately, PNAC does not have the mandate for granting for certifying this this standard. So we are in a process. ISO 9001 certification has been provided to our organization by the CESP, Services of Pakistan. So now PNAC is trying first to accredit CESP for 19443 standard, and later on CESP will grant certification to our organization for this standard. Overall experience our organization is having, particularly the Directorate of Instrumentation and Control. You can say that over the period of time, over the several 2 decades, this directorate has delivered successfully, installed, commissions, and the systems are operated. 150 plus, we can safely say. When instrumentation and control systems, particularly based on PLC or DCS, distributed control system, they are normally measured in terms of IO, a number of inputs and outputs. The outputs could be, the input could be digital, the inputs can be analog. When we talk about analog inputs, it can be a 4 to 20 milliampere current, it can be voltage signal, it can be an RTD, it can be a thermocouple. And similarly, the output signals are also similar. So normally the scale of the project is quantified in terms of the number of its IOs. And the greater the number of IOs, the greater would be the number of controllers, the greater would be the size of the distributed system. So this 12,000 figure, this is the largest system, and we have delivered 3 such systems of this scale. The kinds of INC systems we are dealing with are DCS-based control systems. You can say more than 20. PLC, programmable logic controller-based control systems, and motor drive automation. These are things like overhead crane, in which we have 3 motion in 3 axes. When the crane is moving along 1 axis, the trolley over the crane is moving at 90 angle to that motion, and the hoist is moving along the z-axis, you can say. So motor drives automation, these projects we have accomplished successfully. Next is DCS. This is the DCS that I will talk later on perhaps in the last or the second last slide. This is our indigenous system. This I will cover later on. And indigenous hardware, since we are having a number of labs, the development facilities that I already talked about, we have multiple labs, we have a number of labs. And microcontroller, microprocessor based, and nowadays our strongest thrust is on FPGA technology, and I can safely claim that we would be one of the leading, if not the top one, but we must be in the leading organization having expertise in the FPGA technology. These are the platforms. Honeywell Experience System, we have Deliver System, Yokogawa, the brands in front of the icon. Subcon and Holysys, they are Chinese brands. Subcon is spreading very rapidly. Holysys is an equally good brand from China. These we have deployed on various projects. And when it comes to the PLC platforms, we have immense experience. Our team have delivered successfully large number of projects on different sites of different kinds, of different sizes, of different scales. Siemens, with Siemens, we have the maximum experience. With the National Instruments, we have a different kind of experience when it comes to fast data acquisition, when it comes to some special kind of situations. There come the roles of National Instruments and Advantech. Advantech we have used also, for example, at one of our sites, we needed almost 1,000 digital inputs to acquire with a resolution of 1 millisecond. So for that, Advantage and National Instruments, along with PLC that have PAC, which they call Programmable Automation Controller. PAC has is an intermediate platform between the PLC and the standard PC. It has the robustness and the ruggedness of a PLC, and it has the processing and networking capabilities of a PC. So nowadays, very common concept. We have a number of development facilities. Plant automation, this is one of the division, but it is having 2 or 3 labs. Some labs we have designated, for example, it can be a design lab. Another lab where the design, the system that has been designed, that is developed over there. And in another section or another lab, the overall system is going to be under factory testing or integrated testing. Plant automation system, because of having its distinct area of applications, is having its own set of labs. Industrial control system is another direction, another division. Next is the indigenous distributed control system. That product is heavily used in the industrial control systems division. Nuclear instrumentation, as we heard and learned in the previous talk, in nuclear instrumentation, for all our plants, we provide technical supports. The obsolescence issues that come, the repair and maintenance jobs that come, the nuclear instrumentation division is providing services on that front. Electronic and FPGA. On FPGA based devices, we have successfully developed very special kind of devices. For example, we have delivered RIID, radio isotope detector, radio isotope detector. Similarly, we have delivered chronometer, which can measure time with the picosecond resolution. And some particular labs, PCB stuffing and soldering, providing centralized facilities to all the divisions, and some common labs that are already talked on. These are the 2 testing facilities which can be of great interest to the audience, and particularly the audience in Pakistan, and particularly the organizations and universities working in Pakistan. I don't think there are some significant facilities on the verification and validation of software-based INC systems in Pakistan. Software testing is a very big issue, is a very big challenge. And there are certain organizations, certain entities within Pakistan working in this area, but we have developed very, very special skills, labs, facilities, and a very, very dedicated team in this area. Usually, they are following a V model, which covers the entire life cycle of a project, starting from requirements, specifications, and a hell of iterative discussions between the developers, between the testers, between the verifiers, the validators. And when the requirement specification phase is consolidated, it is approved, then the next move is to the design phase. The design phase is once again working under a hell of processes, procedures, and standards, and strict compliance and strict demonstration to those requirements is of ultimate importance. Once finalized, then the team moves to the development phase, and then to the integration phase, and then to the validation and final testing. But even then, it is not like waterfall model distinctive. They are iterative they are having feedback with the previous stages. So in V&V verification and validation, our microprocessor system, microprocessor-based system, even microcontroller-based system, and FPGA systems, which are having software, they are bound if they are to be applied for safety applications. Safety integrity level 1, safety integrity level 2, or SIL 3, and in the nuclear sector it is SIL 4. Although we have yet not built any application for SIL 4, but up to SIL 2 we have designed and developed very successfully under. For SIL 3 level, we are almost done, and we have produced some instrumentation. So this verification and validation facility, this is one of our flagship facility that can be of very great value to the audience in this. Similarly, the cyber security assessment, when a safety related system, or even if the system is not a safety related, it is an industrial grade system, but if it is going to be installed on a nuclear power plant, whether it's based on a Siemens PLC or some DCSR PLC based on Chinese technologies, right from arrival of the system into our premises, the cybersecurity evaluation starts. First of all, they test and validate the system from their own aspects, and when it comes into the lab, during design, development, requirement specification before the first till end of the project, the cybersecurity people, they work side by side with the development team. They are integral part. And once the system is developed, when the system is ready for shipment to the site, our internal team, because there is a concept of independent assessment, then there are some cybersecurity teams in our headquarters and some other areas. Those guys come into our organization, and then they collectively perform cybersecurity assessment and testing, in which there are some emissions tests. They are having some equipment and assisting the system, whether the system must not be having some pre-installed malware or some pre-installed device transmitting some kind of signal. And they are also rigorously going to test the network, for security, for vulnerability, and the softwares that are installed, and how it can be detected if a malware or an unknown software comes on the network. So the kind of testing they perform rigorously. Once they certify the system that it is safe with respect to cybersecurity, then it is allowed, and then the system goes into the shipment and transportation process, where it is properly packaged, shipped to the site, and then installed and conditioned over there. So these two are very important facilities we have developed. Another kind of qualification facilities for safety systems, the functional and performing testing is not sufficient. All pieces of hardware equipment that are going to be deployed for safety application, it is very, very important that they pass through environmental qualification. Environmental qualification are normally humidity and temperature related testing. We have environmental qualification facilities at least 3 places, and they can be approached from Pakistan if somebody needs. EMC qualification, IEC 61000 series of standards. It is a set of almost more than 20 standards. We are having all those standards, and other IEEE and IEC standards regarding EMC qualification, and even environmental qualification. We are having all those standards. We have developed procedures, processes, and all those facilities where these tests are being. One thing very important I want to mention over here, that the previous two facilities, they are directly in our organization. They are under the support engineering directorate. But these facilities are not within the boundaries of our organizations. These facilities are in our sister organization. You can say the PAC, Pakistan Atomic Energy Commission, different other institutions. They are providing the environmental qualification, the EMC qualification, and I think EMC standards are there are almost more than 30 different kinds of qualifications for example, if the instrument is going to be operated in a power plant, or it is going to be in an electrical grid, or some in the vicinity of telecom tower, for each and every kind of RFI and EMI, they can provide qualification test. Seismic qualification, we have developed a very, very recent and very state-of-the-art facility at HMC3 in Texla. Seismic qualification for safety systems is important. If the system is going to be installed in a nuclear power plant, so our own developed system, hardware system, they have to pass through this. Verification and validation, we have already talked on. And network and computer security, this is the same one we talked in our previous slide, the cyber security. So if the device is analog device, is being indicated on the left side, so it only goes to the first three qualification tests. And digital system are bound to go through all the five qualification tests, apart from the functional test. And the verification and validation, the functional tests are rigorous, they are exhaustive, they are. Now, due to the changing situation in our country, and particularly the agenda of this forum, we have very recently developed a facility which we call FIICS, Facility for Indigenous Instrumentation and Control Systems. In the previous slides, as you see, we are buying some PLC or DCS-based systems from the international suppliers like Honeywell or Siemens or Yokogawa, Japanese brand, ABB, and so on. Now, the strong emphasis is on the indigenous development to have some technological self-reliance and independence, and we are facing very serious kinds of international embargoes in this sector, particularly in this sector. And also, there is a thinking in the top management that we should raise our commercialization potential. If we, so far, on the commercialization front, we are not active, but this facility is very, very recent, and what we are going to apply over here and use this facility for some customized automation solutions. These are the needs of our various plants. Process instruments, for example, process instrument has been on the track. And the first process instrument that we have chosen is the pressure instruments. Pressure instruments, apart from measuring pressure, the differential pressure instrument can be used for measuring flows, and it can be used for measuring levels as well. When we analyzed the pressure instrument, the different constituent parts, there is a mechanical enclosure. So we are having very good sister organization in the field of mechanical manufacturing, and one such our sister organization is based in Karachi with the name NEW2, Naval Engineering Workshop 2, Karachi, which is responsible for making very fine, sophisticated kinds of small miniaturized mechanical devices or mechanical components or mechanical closure. We have another one with the name SES, Scientific and Engineering Services in Islamabad, also called New One, Naval Engineering Workshop 1. And then we have HMC3 in Texla, which is responsible for making very heavy mechanical structure. So the mechanical enclosure for the process instrument we are having already installed base. We don't need to make another facility. There is a requirement of small PCB. For the PCB, we already have one of our sister organization with the name Smart PCB, which is the topmost leading PCB manufacturer and designer in I think in Pakistan, working under KRL and also providing service in the open market. Similarly, we another component, the sensing element. So the only thing which we call a sensing element, whether it's a capacitive-based sensor element or a piezoresistor-based sensing element or a strain gauge sensing element. So just we have to buy the sensing elements from the market, nothing else. Then the small level signal, we need some processing electronics for which we have capabilities in our organization, FPGA-based, microcontroller-based, microprocessor-based. And the signal can be output in terms of 4 to 20 milliamps. It can be output in terms of voltage 0 to 10 volt or 1 to 5 volt. Or even the instrument can be a smart instrument with a digital communication protocol for integrating the system. So in this direction, our journey is on the road, is on the way. So process instrument. Soft PLC, this is a very flexible product. Although we do not make soft PLC the hardware component, we simply take an SBC, a single board computer from the market, and that single board computer, a Linux-based system, Debian. Debian is a Linux system that we install, and with another patch of software, we convert this PLC in a real-time operating in a PLC with a real-time operating system. And then we can interface a very great number of I/O modules, off the shelf or our own developed modules, and it is a very flexible for any size of application and for any kind of application. This is also one of our very important products. Simply, we need the drive for the I/O module that is going to interface with it, or we must be knowing the data communication protocol. Since the I/O modules in the market are the packs of I/O modules in the market, they provide their own communication protocol. We can very successfully integrate this soft PLC with that product, and we can so you can say that it's a very good effort and a very important indigenous effort. FPGA based devices, I already talked about a few devices: a chronometer, a rate meter, and radio isotope identification devices. These are few of our successfully delivered. And for the soft PLC, we have also developed the input-output modules. The input-output module, we have all variety of modules indigenously developed in our organization. They are.
Mr. Mahmood?
Yeah.
Pardon me. We are running short of time. Could you please wind up?
Okay. This is my second lab. This is the Nexus architecture. On the HMI layer, we have a supervisory HMI software of our own. We have developed with the name Colob Configuration and Logic Builder operator station. And the data communication network is redundant. The controllers are redundant. And one of our this is another fire detection alarm system. This is one of our indigenous product. The control panel with the name Shark, and the HMI software with the name Synos. So in our whole range of buildings, in our state organization. ICCC is responsible for installing the fire alarm and detection system. The detectors we purchase off the shelf, and the control panel and the HMI software that we provide from the ICCC. Thank you very much.
Thank you.
Two questions.
Thank you very much. We are open for questions, and we'll start with questions from our president. Sir.
I've got two very important questions for you.
Welcome.
Mr. Mahbub, we are extremely happy to know that you have established FIX. And I'm not aware, I would like to know whether your FIX is already established and operational. Number two, whether the facilities are accessible for civilian use. Whether you've got a website, who is heading it? These are the queries that I need to be answered by you.
Yeah, as you know, we are a bit reserved organization. We are not very open, but the services are open for the whole of Pakistan. You can approach our headquarters the way you approach for this presentation, for participation in this presentation. We welcome each and everybody that is used for civilian use. Yes, you can have, anybody can have the facility. And rather FIICS that I talked on, it is going to be in a lower category with respect to security. And the process already under process, and very soon we ourselves inform you. Anyhow, even at this time, you can avail the facility. Anybody from Pakistan, they can avail the facility.
Very good. Okay, number two, our healthcare industry in Pakistan is using a lot of equipment, using detection for diagnostics and treatment. Is there any authority regulating the safety and validation of this equipment?
The medical devices, I think, are regulated by DRAPs, the medical devices. And for the industrial safety application, PNRA, Pakistan Nuclear Regulatory Authority. Even the X-rays working in Pakistan, they are under their jurisdiction. Pakistan Nuclear Regulatory Authority.
Yeah, that's right. But you think that this Pakistan Atomic Energy regulating body is also looking after the use of detection equipment, radiation equipment by the healthcare industry?
Yeah, we have our own chain of hospitals for the cancer in Peshawar, Irnam, in Islamabad, Noori, in Karachi, in Quetta, Faisalabad, in Swat. We are ourselves operating.
Thank you.
Okay.
Thank you very much. If there's one more question, I can accommodate.
Okay, I have one question from Dr. Mahmood. Dr. Mahmood, you talked about the containment pressurization test. You do it. So how often you do it, and how you monitor the concrete degradation strength during the test?
Basically, the concrete, there are embedded strain gauges and RTDs along the periphery at different elevations. And we are instrumentation engineering people. Our responsibility to acquire the data and present that data in analytic graphs to one of our organizations with the name WASO, which is responsible for the structural and the civil structures. So they are the people, and another organization from Lahore. Basically, the civil structure they analyze, but we just acquire the data, turn the data into analytical graphs, and in most cases, we are already having from the designer some reference values that the data you acquire must be at the set point level. So even
but that data is for the beginning, na? For example, after 10 years of operation, of course, the concrete strength will be much lower. So you might have to adjust your pressurizer limit also. So I just wanted to know how the mechanism works, how you determine that.
Yeah, but this test is performed in stages. For example, up to 10%, and then stay over there for a few hours. Then to the 30%, 40%. In 5 stages, we reach to the design pressure, and at each stage we wait for a few hours. And this is I think the important point that you are talking about. If we know something abnormal at this stage, so perhaps some corrective measures would need to be taken.
Thank you. Although I know we have one more question from Dr. Moshahid, I would request him to please wait till the end of the presentation. Our next presenter who is waiting is Mr. Nabil Khan. Thank you. Before that, I'd like to thank you, Mr. Mahmood Shah, for excellent update on what
Yes.
we are doing.
We are very happy.
Thank you very much. And now I move on to Industrial Instrumentation in Pakistan by Mr. Nabil Khan, who is Project Manager of Bin Ghalib Engineering Limited, Dubai, UAE. Over to you, Nabil.
Assalamu alaikum and very good morning to all of you. Am I audible?
Yes.
Okay. Thank you so much for calling me for this session. I would like to share the presentation first.
Nabil, अपना background भी बता देना यार जरा कहाँ से तुमने qualification की हुई है जरा.
Yeah, sure, sir. I will start with my introduction. Myself, Mohammad Nabil Khan, and I'm an electronic engineer. I graduated in 2012 from NTT University. After that, I joined National Refinery as an instrumentation engineer back in 2012. And I worked there for like 6-7 years in oil refinery. Currently, I'm situated in Dubai, and I'm working for one of the system integrator, Bin Ghalib. And we are the service provider for various automation project and instrumentation related project. And I'm handling their view of the project as a project manager. So this is my brief introduction. Like I have a background of 10 years of experience in the instrumentation field. So I would like to share some of my views and my experience and my understanding regarding the instrumentation resource in Pakistan, and we'll try to give some views what is going on outside of Pakistan and what are the demand and opportunities related to this field. So this is all about this presentation for this scope and career prospect in Pakistan and beyond. Starting with the basic understanding what exactly the instrumentation engineering and the difference between the classical, other mechanical and electrical. It's like we more focused on precise measurement of instrument and the sensor values, and based on that control occurs, and the focus is mainly on the precise value. Like in electrical, mechanical, however, these all fields are interdependent. It's not like any of the field we can consider as independent and can solely work. However, right now in the modern world, all these fields are interdependent, and instrumentation is more on precise value measurement. So this is a basic difference you can understand, and it is a low voltage control, low voltage level system that having a difference between electrical and instrumentation. So the efficiency totally depend on the sensor values and all these things, and based on that we control the final control part. This is basic block diagram. I just want to share. Everyone might be aware of this basic control system. Automation actually starts with this sensor. When the sensor or transmitter senses the value, it gives to the control system. This control system can be individual controller, or it could be a PLC, DCS, anything, which decides that based on whatever the value it is receiving, what action it has to be taken, and it gives to the final control element. That final control element gives the feedback after taking an action, and that feedback again goes back to the sensor. So this is the basic loop and basic automation philosophy. If we go up into the detail and the new system, all these system working on basis of this control system on this loop drawing. More specifically, if we just see this is another example, practically how it's working. We have level transmitter here, which is a sensor. Earlier in the block diagram I was showing, and this is the main parameter that we are measuring, the level. Once the level transmitter senses the level, whatever the level it is, it will give the output to the control part. That is the controller or control part, where we give our set point, desired set point, that level should remain there. Based on that, controller decides what it has to do. It gives the signal to the final outcome, output device and control element, whether it has to open the valve to maintain the level or close it to achieve the certain desired level. So that is the practical example of level transfer. Now, in today's world, we have all these things working in single control device, single device you can understand. Like transmitter is also has the capability to decide and work as a control system, and there's a final element also have that capacity to work as a level transmitter and directly getting the value. So, but on the fundamental level, all these things are working in this way. We have wireless transmitters and these type of things, but it will remain work on this phenomenon. So this is the basic idea that I want to add in this presentation before going into detail. So the question is, who should choose this field? There are certain traits and personality that a person should understand before deciding to give his career into this field. Like he should be passionate about technology, because every now and then we are coming up with new protocols, new devices, and new standards. So he should be well aware of these things. If he is interested in the latest technology things, then he can better understand this field. Then there is another trait that I would like to add, like problem solving capability. The person should have problem solving capability with his puzzles, chess, and these type of things. If he feels like he has interest in this problem solving analytical mindset, then this field of instrumentation, and mainly these traits are the basic requirement for other engineering as well, but specifically talking about instrumentation, it is highly recommended to have these understanding, because most of the time on the field you have to come up with some out of box solution. So you have to deploy some new control system to cater the risk and mitigate the risk. These type of things require problem solving capability and analytical mindset. However, there are several devices and several systems already available. You don't have to invent the new wheel, but you have to come up with the proper solution. That is the challenges we normally face in the field of instrumentation that I have been facing all these time. So these are the basic criteria or trait the person should have, and then he can pursue this career as instrumentation very well. Then what are the challenges? What I understand, I listed some of them, like limited awareness and industry recognition. One of them is like this, and many industries considering it as a sub-discipline, and I've seen in many industries like mechanical engineer, sometimes electrical engineer, fulfilling the role of this instrumentation, but it gives the at a cost of productivity. If you have the dedicated engineer for this role, then it will be better for that industry, better for that company. So the thing is, limited awareness and industry recognition is very less. And then heavy dependence on import. That is another challenge that causing instrumentation, no major local manufacturers are available. So that's why we are totally dependent on the high cost and delays from the imports, and due to that, we are dependent on their engineer, their services. So this is another challenge that we have to cope. Then there is skill gap also. skill gap and outdated education. Because I remember back in 2008-9 when I was doing engineering, there was only one course related to automation throughout this 4 years of career in electronics engineering, and that was industrial automation in third year or fourth year, I remember. So maybe I don't have the current update on the curriculum, but I feel like there is a skill gap as well as outdated education, not at university level, but before that also in the pre-engineering level. Also, we have to encourage our students for instrumentation and automation related stuff, and we have to bring in the curriculum related topics nowadays. All these things are interlinked, like cybersecurity also linked with instrumentation, because we are not solely doing the automation on the field. We are giving the data to another location. So how it's going over the internet, it's going over the different mediums. So the cybersecurity comes into that, and then IoT also come into that area. So these type of topics we have to introduce much earlier before they enter into the actual engineering phase. So this skill gap and outdated education is one of the concern and one of the challenges that we have to mitigate. Then there is a shortage of career opportunities because of all these previous points that I highlighted. It creates less career opportunity in the field. People are more willing. I mean, industry people are thinking like they can manage this field of instrumentation and automation with another engineer. There is no requirement of specific automation and instrumentation engineer, and so this type of thing is actually causing career opportunities. Few dedicated instrumentation roles available. No design engineers are available. Most of the design we ask from the other companies from outside Pakistan, and based on that, we deploy the system and solely depend on their design. Then this is one of the challenges that we have to work on. Then resistance to automation and modernization. We hesitate in putting new updated control system, like back in 2013 when I joined National Refinery. There were very old control systems. Some of the systems depended on the old classical relay-based system. The whole boilers of the refinery control system was based on pneumatic system, relay-based system. So the thing is, adaptation to the new technology is the challenge that we have to take. So some of the industries has taken that challenge, and based on that, they want to upgrade their system. In that case, they have to employ new specific role engineers, and that is the thing. That's why they are not willing to modernize themselves, and it actually gives more productivity in the end. But the thing is, they are very resistant, I feel like. So this is another challenge that we need to think about it. So fear of job losses are also because of this, and many industries still have outdated legacy system. They are working on it. They feeling like it's fine, but the thing is, we have to update as per the current condition of the market. Some of the areas which are the responsible for this field, like the textile, there is instrumentation, agriculture, fertilizer, the area in agriculture sector, manufacturing industries, then oil and gas and power generation. All these are the sectors contributing to the GDP, as well as instrumentation fields can have their places in these industries as well. So these are the industries that I just want to show in the form. We have our universities giving some courses, specialized program also, like top university institutes we have, and they have the program. But the thing is, we have to include some projects in our curriculum, which should be linked with the industry directly, and not specifically on a theoretical base. We have to teach them, because practical examples and practical projects make the student learn more on the subject rather than theory. So we have the programs available in universities, but the thing is, they have to update it and they need to bring some specific courses related to automation, cybersecurity, industrial 4.0. These areas are very important these days. And what are the new standards the world is working on, how the data is transferring, how the data is working. It's not just about a simple sensor or transmitter. We have to understand what is going on in the world. So this will help them for a career, as well as it will help Pakistan industry as well if they implement these type of things in the industry. So these universities have some programs. I have no current update exactly what is the curriculum going on, but we have a very good name in of universities which is working and giving courses for instrumentation engineering. So industrial sectors, some of the industrial sector I just want to highlight, like where I have worked and what sort of instrumentation I experienced. Like the first is oil and gas. There was a design control system opportunity for drilling, refining, and petroleum, petrochemicals. I was working for process control system, the opportunity is very good in that domain, and there are so many areas like PCS, PLC, SCADA. I got the opportunity to train myself over Yokogawa PCS control system from Singapore, and that is one of the best DCS I have ever seen. Like it is robust, Japanese quality, a Japanese make system. So this is a very good area for the engineers, for the professional to learn, because currently every automation, even here in Dubai, is working solely on SCADA, PLC, and DCS. And it's not like they are using some hi-fi kind of system. They are using the classical PLCs and SCADA. But the thing is, we have to utilize all the features of this, transmitting the data to some other location. We have to use those modules and everything, and this will give very good output, because what I've seen in back in Pakistan oil refinery, like the data was only revolving inside the controller. That's it. We were not able to pull that data in front of management desk. So in that case, we have to get the printout and we have to manually fill those sheets. But there are systems available that can easily provide the data in the form of GUI in the management mobile phone or their tablets, so they can understand that what are the KPIs going on the plant. They don't have to inquire every time. So deploying this type of thing will give more productive decisions, and that. Then there is another domain that I call RO, plant water treatment, that is very interesting, as well as it has very so many you can say control system related to flow, pressure, chemical dosing system. I joined one of the projects that we installed one of the largest RO for Canap, and that was one of the great projects that I worked for. And during that project, I worked over several different instrumentation related to RO water treatment plant. So this is another area that there's opportunity for instrumentation, and we have to encourage this domain, and we have to deploy some positions there as well. Then there is MEP design forms like mechanical, electrical, and plumbing, and a BMS form. Like in many building, there is fire alarm system that is automated. Then the BMS data, then energy efficient lights and energy efficient system, and the data from the building that is IoT based system. So these type of automation and instrumentation is also included in the building management system, that we can get the opportunity here as well as an instrumentation engineer. So these are the areas which I have experienced. So that's why I just included in this presentation. So what next is like job roles and for instrumentation engineer. Now we need to understand what are the roles available for an instrumentation engineer in the market, in the industry. Starting from technical role, basic role like instrumentation control engineer, you can start as a basic instrumentation control engineer. Later on, he can be specialized to any PLC, SCADA, or DCS system. There are several different PLC brands. So if wherever if the person is working, if the industry is working over Siemens-based PLC, that is good for him. He can make himself familiar with the environment of PLC, Siemens PLC, the system, its programming, and all those. Then there are several DCS, so he can make himself specialize in that particular DCS, whatever is working in his industry. So these are the areas or technical tools related to instrumentation, like DCS engineer, PLC engineer. Then we have automation engineer, overall automation engineer, not dependent on specific to any brand or something. Then when we go to the specialized position, it's like system integrator that use different PLCs, different DCS, and how to communicate one brand of PLC to another brand. What are the module used? So these type of challenges comes when you work as a specialized position as a system integrator. And then we have process control engineer positions, and then maintenance and reliability engineer. This is more specifically dependent on the industry process, whether it is a fertilizer process or refinery process. So that is another role. Then at advanced career, like if you all aware about all these areas of automation, then you can run the project. So you will be the project engineer. You not only handle the automation, you have to handle the project requirement and objectives as well as the client requirement. So this is another broader area that you have to manage based on based as an instrument engineer. So you can be a project engineer as well. And then there is consultant and design engineering post that you can be part of a design firm and give design related services to the industry, to the client. And then there is technical sales engineering at the end. Like once you have a good understanding of all these areas, so there is a role available for as a sales engineer, technical sales engineer, and business engineer. That the one only that person can only give better pitch who has a better understanding on all these areas and experiences. So these are the job roles available in the worldwide market, as well as some of the roles are available in Pakistan also. So this is the thing that I just like to add in this. Like these are the job roles we have. The next is I thought I should add some UAE-based instrumentation information. Like the field of instrumentation is very high demand here in Dubai. Like everything is totally automated and dependent on the control and the sensors, whether it is the tool, fine, and parking, everything is totally automated. So the demand is very high for instrumentation and automation engineer. Like there are major employers, ADNOC for refinery area, they work for electrical side. OEM are directly working here in Siemens, ABB, Yokogawa. So as well as we have the you can say opportunity, but we have the competition is very high also. It's not easy to make a place in these areas, in these big joint, big names. But the thing is, the field is very high in demand here in Dubai. So the oil and gas and construction, smart city, and industrial automation project going on. So my company, we are giving services to our client for system integration. We are integrating the existing system. We are giving new control system, and this type of services we are providing. Valued skills. What are the valued skills? The profession should have like PCS expertise. We should have. Then we can easily make this position here. And then the person should have skill related to SCADA, PLC programming, cyber security, IoT. So this is all related with instrumentation. So that's why I was saying instrumentation is not only sensors. It is now, not now exactly from the start. Actually, it was interlinked with all these domain of cyber security, IoT, PLC programming, and everything. So these are the valued skills for UAE-based instrumentation. So how we started from relay-based automation. this pyramid demonstrate like we started with the relay based automation earlier before all this PLC DCS relay based system were here. Then later on with the modernization, with the update with the system, we come up with the plant process automation with the loop controllers, individual loop controllers, still not the PLC or DCS or computer system or screens. Individual loop controllers, the same loop controller I've seen in refinery back that time. And that loop controller we upgraded into DCS in our refinery in 2017-18 with the Yokogawa DCS. So after this loop controller, we shifted to the DCS and SCADA PLC based automation. So all the processes now controlled with the PLC system. Each PLC is controlled by and monitored by the DCS system, and those DCS is remotely monitored by the SCADA. So this is the hierarchy. This is another topic that DCS, PLC, and SCADA that we can have another session regarding this. So this is, the third level is like we move to the PLC based automation, SCADA based automation, and DCS. Once we move to the SCADA, so there is a need for cyber security. So this is another domain that came in the picture after so much communication of the data over the air. So the cyber security is the basic requirement now. And above that, digital transformation is the current state, which includes IoT, AI, smart sensors, and so many more updated things are there in the market. But the thing is, we can use these high-tech devices as well as we can use the classical instruments as well to make our production, make our industry more productive. It's not necessarily required like we directly have to jump to the digital transformation level, sensors and things. We first have to automate and make our process more productive. Then slowly and gradually we can move to the next level. But right now the world is on these digital transformation level, which is IoT, AI, and smart sensor based. And that is the future of instrumentation engineering, and it going on and on with the new tech and new technology. So instrumentation engineering is a dynamic field with endless global career opportunities. In short, so in order to promoting instrumentation control indigenous in Pakistan, like some of the point I just listed down, like establish local manufacturing and R&D centers that will promote instrumentation, develop local production of sensor transmitter that will give more opportunities to the people with the instrumentation. This will encourage the R&D area as well. The government should offer incentive and subsidize to instrumentation startups. Then upgraded education again, then training and specific courses and certification should be there related to the updated technological topics like IoT, Industry 4.0, AI. However, these are going on and there are several courses available. So based on that, if we enhance it more, so it will help to promote this instrumentation and control in Pakistan. Then there are some other aspects like strengthen local system integration companies, encourage local firms to design and implement DCS, so that reduce the dependency on foreign equipment, foreign machinery, foreign services. So we can soon be dependent on our manpower, our engineers, and we should, in that way, government has to play some role to provide that incentive for companies investing in automation solution, because ultimately it will give overall productive output for that particular industry. Then promote industry academic collaboration with the university and industry. We have to increase more projects which is to promote industry and academia, and set up joint research projects between universities and industries, and establish incubation centers that can be done. Also introduce internship and apprenticeship with leading control system companies. We have to ask the main OEM like Siemens, Honeywell, Yokogawa, Schneider, we come and give projects to the industry or academia students. Then government support and policy reform. We should not ignore this. This is the main thing that we require, like create a national strategy for instrumentation and control. In that way, we can promote instrumentation and control in our country, implement local sourcing policies, that how to source the instrumentation projects, fund pilot projects to showcase examine the automation solutions. This type of steps the government should take, like in that way it can be promoted. It can promote instrumentation, increase awareness and professional networking. Organize conferences like this one. This is very good session that we are having, giving so much information on this topic, like webinars, automation related to automation instrumentation, develop online platform, competition, programming competition, or project pitching, and these type of things we need to promote in the circle of professionals. So this will also promote instrumentation, and by focusing on our local expertise, education, industry overall, we can promote sustainable instrumentation in the country. So this is from my side, and I hope I have covered more on this topic. And if there is any concern or if anyone wants to be in touch with me, with contact. Thank you, everyone.
Thank you very much.
There is one presentation also. There is one video also. If we have time, we can run that one also. Dr. Hassan, if we have that video, can you just play what is exactly the automation, the name of that video?
Welcome to another video on IT and Automation Academy. Today, we're going to explain SCADA in a super easy to understand way with the help of animation. I want to understand what SCADA is. So, what is SCADA? SCADA stands for Supervisory Control and Data Acquisition System that helps monitor and control different processes like oil and gas, power, and more. Before we dive in, let's understand two types of architectures, factory-centered and remote. Let's start with factory-centered SCADA. In any process, you need instruments like control walls, transmitters, VFDs, and motors. These instruments collect data, which is crucial for making decisions. Now, imagine these instruments as sensors in our body. They collect data about temperature, pressure, and flow, just like how our body senses heat or pain. Now, this data goes to PLCs, which are like the brains of the operation. PLCs analyze the data and decide what actions to take. For example, if there is some changes required in process, PLCs send commands to final control elements like motors or valves to meet desired process requirements. So the PLC serves as the central processing unit of the SCADA system. It receives data from field instruments, processes this data according to predefined logic and algorithms, and sends control commands to actuators and final control elements. PLCs are highly versatile and can be programmed to adapt to different industrial processes. Let's understand in super simple analogy. Let's imagine you're driving a car. In this scenario, imagine if your car could drive itself. The autopilot constantly checks the information from the dashboard and makes decisions based on that data. For example, if it detects that you're going too fast, it automatically adjusts the speed. When the autopilot decides that something needs to change, it sends commands to the steering wheel and brakes, final control elements, to adjust the car's direction and speed. Similarly, in a process, if the PLC decides that something needs to be adjusted, it sends commands to motors or valves to make those changes. So, just like how an autopilot guides a car safely to its destination, PLCs ensure that processes run smoothly and efficiently by monitoring and controlling various parameters based on the information provided by instruments. In PLC, you can't directly observe the ongoing processes or the temperature within them unless you establish a connection using your laptop or access it online. Alternatively, you can link it with an HMI, which stands for Human Machine Interface. As its name suggests, an HMI serves as the interface between humans and machines. Through the HMI, you can visualize the status and values of various processes in real time. Next is Engineering Workstation. This is a computer system used by engineers and system integrators.
What is industrial automation? What is industrial automation? Automation is the use of machines to carry out manufacturing processes with little human involvement. Industrial automation allows for facilities to utilize these processes for a more optimized operation. Manufacturers use machines that are operated through different control systems, like programmable logic controllers or PLCs, human machine interfaces or HMIs, and robotics. Automation uses logic and programming to feed the machine information on how to carry out a function. These machines allow for high control, which improves manufacturing performance. There are a few different types of industrial automation systems. Hard or fixed automation is made for repetitive tasks with high turnout rates. Programmable automation is used for batch production, where the automation process can be modified. Soft automation allows for flexibility and changes to products quickly and easily. Some of the benefits of industrial automation in a manufacturing environment include high reliability, increased productivity, quality enhancement, and reduced labor expenses. Industrial automation in a manufacturing environment may include various types of equipment. Automated material handling systems such as Swisslog AutoStore are specialized, autonomous, and compact in size for fast inventory retrieval speed. These systems are customized for the environment and needs of the facility they are housed in. 3D printing machines allow manufacturers to create 3D models of particular items from a computer. CNC machines come in many varieties. To learn more about various types of CNC machines, visit the link in the description below. CNC machines can take material and reconfigure it into a precise form within the operator's given measurements and requirements. Robots complete repetitive and mundane tasks. These types of tasks can easily be programmed and given to a machine to perform. For more information about how Radwell services the industrial automation industry, visit us on the web at radwell.com or connect with us on social media. Thanks for watching.
Thank you, Nabil. Thank you. Thank you. Now we are open to questions. And thereafter we'll follow discussions.
Yeah.
And Professor Dr. Jamil has
I've
several
two
questions.
questions. Nabil,
Yes, sir. Yes, sir.
do you experience embargoes on the procurement of necessary instrumentation in Dubai?
Sorry, sir. What experience for the part? I work, sir, in National Refinery.
Are there any restrictions, embargoes?
Restriction.
Importing instruments from abroad.
No, sir, there is no specific restriction here in Dubai for importing. There is no such restriction.
No, there's no. Okay.
Okay. Now the next question is that you know that South Korea supplied 4 large plants in Abu Dhabi.
Okay. Yes, sir.
Are you aware of the
No, sir, specifically.
implementation control exercised by any agency in Abu Dhabi?
So there are several agencies in Abu Dhabi and Dubai, but I am right now more focused on the project related to district cooling plant and water pumping station plant. I'm not in touch with those agencies or any institute who's working for that South Korea plant.
Thank you. Thank you. Any other questions? Dr. Mushahid, we had some questions to any other author. I have a question from Dr. Mahmood Shah and our other speakers. What specific? We Pakistan can't focus on the entire spectrum of instrumentation. If you focus on a limited area and we try to set up industry on instrumentation, तो कुछ बात बनती है कि हम पूरा पाकिस्तान कांट गो इन ऑल द इंस्ट्रूमेंटेशन फील्ड, कुछ तो लिमिटेड एरिया हो जहां पे हम शुरू करें एंड देन वी स्टार्ट ऑफ एक्सपैंडिंग. हम कोई डिटेक्टर नहीं बना रहे, कोई सेंसर नहीं बना रहे, कोई इसका हमारा वी डोंट नो हाउ टू गेट डेटा फ्रॉम सेंसर्स. तो what is the methodology through which Pakistan should start after 75 years? कि हम कहाँ पे ज्यादा फोकस करें, तो पैसा पूरा लगा नहीं सकते हम, और प्राइवेट इंडस्ट्री क्यों नहीं आई इस एरिया में? खासतौर पे ये PAEC से सवाल है. पाकिस्तान में आप लोग इसको प्राइवेट सेक्टर में करा दीजिए ताकि कुछ लोग आपको अप्रोच करके इंस्ट्रूमेंटेशन डेवलपमेंट में काम करें.
Thank you. This consideration has been developed in our organization because our organization is pretty much big. We ourselves act as a very big customer. So that's why the need for process instrumentation on indigenous scale has arisen and it has been started addressing. I think in the market there are very, very huge variety of options available. As Dr. Nabil said about some integration. So many products from the Chinese market and even from other markets are available. If a person is well experienced in the automation sector, he can provide a variety of solutions from available cheap and cost-effective products. So it's a matter of cost effectiveness, whether you can. So I don't think the market in Pakistan also is not very big, and if the people are not moving towards modernization, replacing their outdated old systems, as our previous worthy speaker said, so it's all. I think the game of business and the game of economy. If the investment returns to somebody and there is some financial modeling, financial analysis, perhaps one might go. Even we after our market assessment and market research, the market is very, very competitive. If, for example, we make the process sensor, the pressure instrument, so the only option we are having, apart from some other marketing strategies, that you select some sellers and some authorized dealers in Karachi, Lahore, Faisalabad market, and those people in the market already they are flooded with numerous supplies from numerous directions. Since we are always also facing embargoes, so in some sectors and in some areas we feel that we should move, but I'm also, since I'm not a financial expert or so it's a bit it's a financial and technical matter also. It is not only technical matter. On the technical front, I think we are having pretty much experience and pretty much skills, and we can develop. But the finance, investor, and then one important thing, the strict compliance to standards and quality requirements. It is of utmost importance. If we can deliver products in the and compete in terms of performance, in terms of features, functions, and quality, so then we can think something about that. It will be very difficult. We ourselves are planning to manufacture with strict and limited features and functions meeting our requirements.
मेरा दोबारा सवाल आप ही लोगों से है who are in this field. मैं सिर्फ ये कह रहा हूँ आपसे कि आपने कहा नंबर्स कम हैं. हमें किसी एक फील्ड में पाकिस्तान की 2-3 चीजें जानी पहचानी है. एक एग्रीकल्चर में, एक टेक्सटाइल में, और एक कोई खाने फूड इंडस्ट्री में, ये सीमेंट इंडस्ट्री है हमारे पास। हम किसी एक एरिया में फोकस करके पहले सिर्फ एक चीज को डेवलप करें, फिर उसके बाद वर्टिकली कंप्लीट डेवलपमेंट और फिर उसको हॉरिजॉन्टल फैलाते चले जाए। ऐसा कोई आप लोग जानते हैं तो आप लोग कोई ऐसी चीज प्रपोज तो करें ना, कोई ऐसी चीज प्राइवेट सेक्टर के अंदर उस वक्त आएगा जब।
Sir, may I add something to it, sir?
Yes, sure. It's a discussion.
I'm Dr. Ahmed Hussain. I have been part of Atomic Energy Commission for 20 years, and then of course almost a similar experience outside the atomic energy. So it's basically the culture. It's a culture in the state organization is very different. Dr. Mahmood is right. They have no motivation, or they have no culture, or they have no ease of doing business. So there are a number of action have been taken by these strategic organizations to bring their technology to market. But when the market contacts them regarding the availability, then they are quiet. For example, one of the potential these trade organizations, they made a public company, and they say we can supply aluminum in the market. For the last 2 years or so, the aluminum was short in the market. But when we asked them about the price, they were quiet. They were quiet for like 6 months. So the market cannot wait for it. So it's a matter of more ease of doing business. I think they are not in that mindset, the strategic organizations.
Thank you, Dr. Dr. Mushahid had a question. Dr. Mushahid,
Assalamu alaikum. Are you able to hear, Mahmood Saab?
Yeah.
Okay. I am Dr. Mushahid from NED University. You have mentioned that in your slides that you are interested in indigenous development of instrumentation.
Yeah.
So what do you really mean indigenous here? Have you got to the question?
Should I reply now?
Yes.
Yeah. Because we are thinking in this direction, because we are already having a very big installed infrastructure. As I already said in my presentation, we are having mechanical department. We are having a very smart PCB manufacturing facility. Regarding signal processing, FPGA and electronics, and these are the constituent and integral components of a sensor, of an instrument. Since many technological requirements are already available, are already in place, so that's a motivation for us to think and move forward. The only thing we are missing is the sensor, is the capacitive or strain gauge or piezoelectric or some kind. So just take that, and that is cheap. That ranges from $50 to $200 to $350 range, and then you convert this into a whole instrument, into a whole transmitter, because we are having the electronics expertise also and the software development also, the software, so we can integrate with it any kind of data communication also as well. So if somebody starts from zero, from scratch, and builds all the prerequisites, it will be very, very expensive for him. Since we are already having infrastructure, we just want to maximize the use of those existing facilities.
Thank you.
I would like to be more specific here. Actually, for example, any instrumentation system, the cost lies with what resolution, what precision level you are intending. So for example, even for an oscilloscope, you can find it for 2,000 rupees or 200,000 rupees. So the question is all about precision and regulation. Is about resolution. What resolution you are taking data. So have you made something? Okay, this is the niche market which we are going to work to start with.
Yeah, we are not focusing on the oscilloscope, but when it comes to a data acquisition system, the ADCs are available very, very cost effectively and at very cheap prices, and with the very resolution you want, from 12 bits to 24 bits. So we are already working with 14 bits, 16 bits resolution. Resolution is not a matter, and resolution and sampling rate, they are conflicting requirements. If you want very high resolution, then the sampling rate would be low. if you want very high sampling rate, then the resolution, you will have to compromise on the resolution. So yes, but we are not focusing on the complex technologies like oscilloscope. We are just focusing the data acquisition and automation solutions, relatively simple and relatively to be applied on simple automation systems.
Thank you. Thank you. We have a question from Dr. Shoaib.
I am more interested in finding out what is happening in the medical field. Say, for example, there are many isotopes needed for medical applications, and you really cannot import it with the half-life that they have from overseas, and customs are holding and this and transportation time. Are there any efforts to really make these isotopes locally that will really help the health aspects of radiation-based diagnostics and things like that? Are there any reactors or others making any pharmaceuticals, radiopharmaceuticals?
It's not exactly what you wanted. Aga Khan University is doing something good, but it's not on the isotopes. It's on the gene okay. Aga Khan is doing some pretty good work in on instrumentation and control, and especially developing those certain genes and things like that. I don't recollect the names at this time. Medical engineering वाले शायद कुछ बता सके, but nothing else. I don't hear anything else. But we have one more question. Probably Dr. Bilal would like to share. Yes, Dr. Bilal.
Thank you,
Dr. Bilal.
Yeah. Thank you very much. I have one question. We have some of our instruments, and these are analog instruments, and we want to replace them with digital smart instruments.
Background बता Dr. Bilal, बाकी सबको अपना background बता दीजिए.
Yeah, I am from Pakistan Atomic Energy Commission and working as a director in electrical system department. And yeah, so my question is, we want to replace our analog instruments with smart digital instruments to make our simple system simple. So my question is from Dr. Nabil Khan, whether he shall be able to supply such instruments to us.
Nabil or Shoaib could reply.
Yeah, or Mr. Shoaib, anyone can reply.
For our campus reactor, we did upgrade our analog systems to digital 10 years ago, roughly. But it does have a huge amount of regulatory, work associated with it. It's not as simple as it is doable, but you will have to demonstrate a lot to the regulatory authority in US, it's NRC, Nuclear Regulatory Commission. And I don't know what will be the framework in Pakistan for doing such an activity. Then there are other risks associated with it, meaning when you convert it from analog to digital, we are able to, and I have taught classes to other campuses using this new device. Urbana-Champaign campus was one. But once you start doing that through the internet, that is what we are capable of now, there are some risks associated with it. So we have given no control. Only they can only view the data over the internet. I can talk a lot about it. We do have a conference paper on teaching long distance nuclear reactor labs with some of my students when we converted that. But it was not an easy path. It was not an easy path, not because of technology, but because of the regulatory aspects of it.
Yeah. So what we can expect regarding the regulatory aspects in how many years you predict that it may be available? Because US NRC is also working on that, and a number of all other regulatories are also in picture. So is there any chance that in coming years we will be able to get such instruments?
No, I don't know. I don't know the regulatory structure in Pakistan. I have no idea. So it's
इन्हें खुद ही करना पड़ेगा.
Okay. Thank you so much.
Nabil, do you have any input on this aspect from Dubai?
We have to adopt the way the things are automated here, and not at a big scale. At least your point of view was correct. Like, we have to start with specific areas of industry like textile or fertilizer. We have to bring these type of automation and system based on our requirement, not just like we directly implement the hi-fi instrument and smart system directly. We first need to analyze what is our requirement in particular area. Then based on that, there are classical instruments itself have the capability and feature that we can make very productive automotive system. So that is the thing that is from my side. Like, we don't have to go directly to the hi-fi system. We can implement these automation projects based on the basic instrument available in the market. But we have to we have to promote these ideas, and we have to promote these ideas at academia level as well as industrial level.
Okay, so
years ago, I'm sorry for years ago, when we were a student in NED, we had the lab for aerodynamics where we could measure that. Saad Umar was the instructor, and a group 1 year junior than us, what they did is that there were strain gauges to measure the movement of that holder for the object that they were in the front of the wind tunnel that was placed. Those strain gauges were measuring analog signal. They simply took that analog signal, converted it to digital, and imported it in the lab in their computers. And I'm talking about 30 years ago, because I graduated in 88. So they must have graduated in 1989. And that data was coming to the computer, and now they were able to really record all 3D movement of the sample that they had in front of the wind tunnel at NED. You can dig up their thesis. All the signals in the analog are either counts or currents, and those conversions are not too difficult.
Very right. Now we have last 5 minutes. Is it possible for all of us do we have an instrumentation society in Pakistan?
So there are so many over the LinkedIn platform. We have very huge different instrumentation groups available.
No, I'm talking of formal. I'm talking of formal society of instrumentation in Pakistan. Just like Pakistan Academy of Engineering. आप लोग तो इंस्ट्रूमेंट के लोग हैं ना, तो आप लोग एसोसिएशन तो बना लेना अपनी इकट्ठी, जहाँ पे पाकिस्तान को अगर डेवलप करना है इन फ्यूचर, तो पहले एसोसिएशन होगी, उसके बाद कुछ चीजें शुरू होंगी. Involve the universities, create an instrumentation group, a large group of people who can actually promote and push the cause of instrumentation in Pakistan. You can have international experts like Shoaib sitting here, and then we go ahead and we focus on to certain areas. सबसे आसान जो है वो एग्रीकल्चर फील्ड है या फूड है इंडस्ट्री, उसके बाद हम एक्सपैंड करते हैं टू द रेगुलेटेड डोमेन ऑफ न्यूक्लियर इंजीनियरिंग. But we can take their expertise and focus on development of certain areas. और जो सिंपल हो, जहाँ पे कहीं रेगुलेटरी चीजें ना आती हो, और उसके बाद हम जब बेस बन जाए तो फिर आप दूसरे एरिया में चले जाएं. तो ऐसा कोई आप लोग ग्रुप बना लीजिए. डॉक्टर जमील ने It was his vision that he said, let's get people on this very sensitive, and he has been talking about this at least for 5 years. कि यार सबसे ज़्यादा weak area हमारा पाकिस्तान का instrumentation and control है. We must do something about it. But ज़ाहिर है, it's not only us. You are the one who are supposed to know things. Pakistan के अंदर कहाँ है? What is the current status? How many people with Pakistani origin are there who are working in this area, who can assist us, guide us, और उसके बाद हम we can take help from our Chinese friends to focus on certain areas, और वो ऐसे एरिया जो regulated ना हो. उसके बाद आगे चले. अब इस पे बात कीजिए for a few minutes.
इसमें I think the lead should come from electrical engineers, because as I showed you in my presentation, post first signal generation, all of this is processing of the signal which are electrical. So,
Okay.
Except for the very first step, rest of it all electrical. So the lead should come from some electrical people who are doing instrumentation. Now the first piece that you can change, either a nuclear device, nuclear measurement device, or any other device. Post that point, everything is electrical signal processing.
Any of our international friends who would like to add their views on this? And before we conclude, Dr. Bushayed, yes?
Actually, actually there is a lot of market. Actually, even if you look at 200 universities in the country, I believe at least if I count 10 instruments are out of order because of instrumentation. So there would be 2,000 projects within the universities in Pakistan. So there are a lot of equipments I know which are not functional, so expensive just because of something wrong with the instrumentation. So even in the maintenance sector, there are a lot of opportunities.
Yes, sure. मुझे बहुत सारी चीजें, but Nabil has raised his hand. Nabil, आप कुछ कहना चाह रहे हैं? Okay, right. Now, we don't have any questions, sir. I request Professor Dr. Jameel Ahmed Khan to give his concluding remarks.
We are very, very happy to have very valuable presentations today. And one of the very important information that we secured is that the Atomic Energy Commission has established FIX. And that would, I think, provide the necessary basis for the dissemination of technology for instrumentation. My view is this, what Dr. Bushayed Hussain has said very correctly, that a survey may be conducted to rejuvenate the dormant equipment lying in the university system.
In Pakistan and Germany.
Only because of the variety of instrumentation which has not been properly looked after. And with the result that the experimental facilities have suffered immensely. On one side, that they cannot be replaced without proper funding. Secondly, if the instrumentation is not provided in time, obviously the students are going to suffer because lack of knowledge, which should be acquired through practice. Engineering is by practice, by and large. Thank you.
Thank you, sir. With this, I'd like to thank all participants for being with us. We'll place the entire symposium proceedings in our website. Kindly visit our website for all other earlier on symposia, which we did. Today was 35th. So we've done 34 symposia on different technologies. They're all placed on the website of Pakistan Academy of Engineering. We very much appreciate you visit that place, help us improve that. We would like you to also suggest if you have a future course of action for Pakistan Academy of Engineering, where we could invite you again for discussion on development of instrumentation and control in Pakistan. Thank you very much.
Thank you very much.
And Khuda Hafiz. Goodbye.
Allah.